message hormone for the T cells. Very important. Over 200 enzyme systems associated with zinc. Copper. Making quality protein in the crops, you need copper as a trace element. Elasticity in the veins and the nerves, the myelin sheath, which is the insulation of the wiring system of the body, depends on elastin. That's a copper-dependent substance. An enzyme called catalase is a copper-based enzyme. What is catalase good for? Catalase shuts off excessive hydrogen peroxide production in the body. Who generates hydrogen peroxide in the body? You all do. Why? Because your white cells make hydrogen peroxide. Wonder why? White cells, immune cells, hydrogen peroxide, what does it kill? Pathogens. White cells create hydrogen peroxide to kill pathogens. But you don't want to be creating hydrogen peroxide all the time. When you have an infection, turns it on. This copper-based enzyme called catalase turns it off. Find out you put copper in the soil, it drives up the levels of vitamin C and vitamin A in the plants. When was this done? Probably 1952. You see what plants do with it? It's not just the mineral you get the vitamins that the plants make with the mineral. So vitamin C and vitamin A. Parasites. We know that copper is an anti-parasitical. It's an antifungal in plants. It's an antifungal in people. And it's imbalanced with zinc. Too much copper is poisonous. Not enough copper means you're unhealthy. I'm going to get through this here and we'll take another break. Manganese. Fertility element. This is not, I'm going to finish with manganese because this is one of my favorite ones. This drives a lot of chlorophyll production, by the way. Let's go through manganese here. What happens in animals? Well, there's this furnace inside the cell called the mitochondria. Anybody hear of the mitochondria? That's where you burn glucose with oxygen, hopefully, and that's where efficient cell respiration goes on. Manganese is one of those elements that is responsible for making sure that the cell membrane is preserved from rancidity. And produces an enzyme called SOD. Actually, copper and zinc also produce another SOD. Preserves the cell membrane from too much oxidation. Remember, you're burning fuel like a stove. Don't want oxidation burning up the cell membrane. SOD is your preservative. It's a manganese-driven, zinc-driven, copper-driven kind of an enzyme system. You know, deficiencies, silent heats, abortion, cystic ovaries, increased percentage of male calf births, and utilization of all the B vitamins, manganese dependent. Old 1953 research, number of inseminations, number of cows in gestation. This is based on manganese deficiencies. If you can't get your cows bred, or maybe there's sterility problems in people, you might want to take a look at manganese. This is interesting. 1951, University of Wisconsin, forages that had less than 20 parts per million of manganese had ovaries that weighed less than 0.65 milligrams. If the forages had more than 50 parts per million of manganese, they weighed 2.0 milligrams. Over 300% increase in the weight of the ovaries. Now, this is interesting. If manganese drives some of the carotenoids, carotenes, what color are carotenes? Orange and yellow? What does corpus luteum mean? Corpus luteum.
It's white body.
Yellow body.
Oh, yellow body. Oh, okay.
Corpus luteum. Part of the reproductive tract of women. Where's the yellow come from? Carotenoids. Where's the carotenoids come from? Fertility. Everything's connected here. That's why you need to understand the importance of the minerals, the substance that was in the soil, the biology moving up into the plants taking that fertility and turning it into these other compounds. This just goes to show you vitamin E levels go up dramatically when there's manganese in the soil. So, you know, one after another. Iron, okay, you know about chlorosis and chlorophyll, hemoglobin, many, many enzyme systems for iron, particularly with women. Concentrated in the hemoglobin. There's different kinds of iron. There's heme iron. Okay, now here's the thing I just read not too long ago. The heme iron is the most important iron for building blood, but the heme iron is also the kind of iron that can create problems. You know, too much of the free iron that feeds pathogenic bacteria, too much of the iron that can be called precursors to carcinogens. Well, guess what you need to do to neutralize the side effects of heme iron while you get the benefits of heme iron? Eat antioxidant-rich foods. Like when you have that steak from a grass-fed farm, you swallow a glass of red wine from Italy with it. All right, you get the resveratrol. I'm serious. Resveratrol, right? Or pomegranate juice if you don't drink alcohol, or something. That's where it comes from. You need the balance of, you know, not just the meats, but the carotenoids that go with that stuff. Molybdenum, nitrogen fixation, nitrogen detoxification in plants and animals. This is New Zealand research, 1940s. One trace element. See, what's good about New Zealand and Australia, they did a lot of this trace mineral research a long time ago because they had cattle problems and sheep problems real early on because their soils are so poor. Australia's got the oldest soils in the world. New Zealand has some of the youngest soils in the world, and consequently they're both very, very deficient, and they're not glaciated either. Glaciers do a good thing, as long as you're not around when they're here. But, you know, once they leave, they do a good thing. It takes a couple thousand years later to really get the benefit, but they actually do make great topsoil. So those soils are poor, and they started having massive problems with their cattle, with their sheep, and they said, you know, we got to figure it out. They knew it was the soil. And they started doing all this research that, of course, we got the benefit from, although our soils are much better than theirs. But just one trace element, they increased the growth of alfalfa up to 600% just with molybdenum. So nematode, parasites, nitrogen detoxification, boron, I talked about this earlier, I'm going to talk about it again. Men, prostate problems, boron. Eat boron-rich foods, take a boron supplement. Massive amounts of documentation. Women, osteoporosis. Boron is extremely important for building hormones. All of the hormones depend on what? Cholesterol, right? Boron is one of those elements that really is important for the sex hormones like estrogen, testosterone, progesterone. And in plants, it moves calcium around, so it makes really hard tissue. And it's the catalyst that allows calcium to get out of the soil up into the plant. If you don't have boron in your soil, you're going to have a hard time getting the calcium to move. And what does it show? Again, same thing, essential amino acids. Albrecht showed this with magnesium. Now we find out that boron does the same thing. Tryptophan, methionine. You see how all these things are connected? Quality comes from inputs. And again, estrogen, all these hormones, blood calcium levels, pH, right? What is the pH of the blood? 7.4. What governs blood calcium levels? A hormone called calcitonin, parathyroid hormone. Where does that come from? Boron. So let's take a break. Another 10-minute break?
No, this is lunch.
Oh, this is lunch. More than a 10-minute break. And then we'll zip on through the food as medicine talk. 150 micrograms of iodine not to get goiter, which they pretty much eliminated with that dose by iodizing the salt. But when you have goiter, that's a near-death experience, like scurvy. You know, you only need about 60 milligrams of vitamin C not to get scurvy. Is that the optimum level of ascorbic acid in the diet when we don't make any ascorbic acid? So not having scurvy is not necessarily an optimum daily allowance. And that's the real deal. What is the optimum daily allowance? Not the allowance that keeps you from dropping dead from scurvy or having a degenerative illness like goiter. Now it's interesting to note that in Japan, which has some of the lowest estrogen-driven cancers in the world, in the industrialized world, I should say. You know, their intake of iodine is potentially somewhere between, depending on what part of Japan you go, because of their high intake of sea vegetables and seafood, their intake of iodine is somewhere between 13 milligrams and even 100 milligrams.